What's up everybody, and welcome to another easy math video. Today's video is going to focus on basic divisibility rules. So basically I'm going to be showing you some different tricks that will allow you to recognize whether a larger number is divisible by the numbers 2, whether it's divisible by 3, 5, 9, or 10. So basically we're going to be looking at little tricks that will allow us to recognize whether these numbers that I've just mentioned can divide evenly into another number. Okay, let's start off with the number 2. It's pretty basic. Okay, basically any number is divisible by 2 so long as it ends with a 0, a 2, 4, 6, or 8. Any even number. All even numbers are divisible by 2. I think that's pretty straightforward. The number could be as small as 16. Okay, we all know that, basically anytime we divide by 2, we're cutting the number in half. So 2 goes into 16 8 times. Okay, it could be as large as 2,468. Any number, once again, that ends with a 0, 2, 4, 6, or 8 is divisible by 2. Let's move on. Now let's look at the rule for whether or not a number is divisible by 3. So basically, any number in which the sum of all the digits is a multiple of 3 is divisible by 3. Now, once again, that sounds like super wordy, and that's sometimes the way these things are written are difficult for people to comprehend. But I'll show you an example. So basically, let's take a number, okay? We'll use a larger number. We'll use the number 243. So basically, if you wanted to know whether or not it was divisible by 3, and that means whether or not 3 could go evenly into it without any remainders, you would take all 3 digits. If it's a 2-digit number, you're going to take the 2 digits. If it is a 3-digit number, you're going to take all 3 digits. And if it's a 4-digit number, you're going to use all 4 digits, and so on and so forth. And what you're going to do is you're going to add them together. So I'm going to take 2 plus 4, which will give me, so let's just do that on the side here. 2 plus 4 gives me 6, plus 3 gives me 9. Okay, so that equals 9. And if you have a basic understanding of the 3 times table, you should know that 3 goes into 9 evenly 3 times. So automatically, boom, yes, 243 is in fact divisible by 3. Okay, we could try another number now. Okay, let's try the number 218. Okay, so that would mean that I'm taking 2 plus 1, which gives me 3, plus 8, which would give me 11. Okay, and I can tell you right off the bat, if we skip count by 3, okay, 3, 6, 9, 12. Okay, so it cannot go into 11 evenly. So right away after doing that, I would know that 218 is not divisible by 3. Okay. Moving on. Now we'll deal with the number 5. This one's pretty straightforward. Any number that ends with a 0 or a 5 is divisible by 5. So that number could be as small as 20, or even smaller, obviously, or it could be a way bigger number. It could be 21,105. Okay, sorry about my 0 there. Kind of hard to draw here. So once again, it really does not matter if the number is a really small number or a really large number. So long as the last digit in that number is a 0 or a 5, it will be in fact divisible by 5. Okay, now let's move on to 9. So The divisibility rules for the number 9 is very similar to 3. So any number in which the sum of all the digits is a multiple of 9. So we're going to do the same thing as we did before. Okay. So we're going to add up all of the numbers in it. It could be a really small number. Okay. Like 63. Okay. So if I add 6 and 3, okay, that would give me 9. So 6 plus 3 equals 9. And obviously 9 can go into 9. So 63 is divisible by 9. And I can tell you, just because I know my 9 times table really well, that 63 divided by 9 is in fact 7, because 9 times 7 is 63. We could use an even larger number. Okay, we could use a number like, let's see here. We could even use the number that we used earlier in the example for the number 3, 243. Okay, so if I added 2 plus 4, okay, that gives me 6 plus 3 equals 9. So this number is also divisible by 9. Okay, and you know what? I'll make it even more challenging now. Let me erase this here. Let's use an even bigger number. Okay, why not? Let's see here. Okay. Let's say that the number was 24,399. Well, let's do this here. 2 plus 4 gives me 6. Plus 3 gives me 9. Plus another 9 gives me 18. Plus another 9 gives me 27. And I can tell you right away that 27 is divisible by 9, because 9 times 3 is 27. So it works. Okay. Now, what if I were to, let's try one other number now. Oops, sorry, wrong function here. Okay. Let's say that I were to, make this 631. Well, 6 plus 3 equals 9, plus 1 equals 10. Okay, and 10, I can tell you right now, 9 obviously cannot go into 10 evenly, so it does not work. Okay, so I just wanted to show you an example where it didn't work. Okay, so once again, if you take all of the digits and you add them together, if you get a multiple of 9, the number is divisible by 9 then. Okay, and the last one, and this one's pretty straightforward and pretty easy. Any number that ends with a 0 is divisible by 10. Okay, it could be 10 itself, it could be 20, it could be 30,000 and 10. So long as it ends with a 0, it will always be divisible by 10. Okay, so let's just quickly recap, and then I'm going to go into reasons why you might use this. So, divisibility rule for 2. Any number that ends with 0, 2, 4, 6, or 8. Rules of 3. Any number in which the sum of all the digits is a multiple of 3. So once again, that's where you take all of the numbers that make up that number, add them together. If it's a multiple of 3, it's divisible by 3. For the rules of 5, any number that ends with a 0 or a 5 is divisible by 5. Rules of 9, exact same as the rule for 3. You take all of the numbers that make that digit, add them together. If it's a multiple of 9, it's in fact divisible by 9. And then the divisibility rule for 10 is if the number ends with a 0, it's divisible by 10. Pretty straightforward. Now, why learn divisibility rules? Okay, here are a few basic reasons why this would be helpful for you. Firstly, simplifying fractions. Okay, when you're simplifying fractions, you need to divide both, top and bottom by a number. Figuring out, if you're dealing with larger numbers, doing trial and error could be time consuming and annoying. If you can find a simple, quick way of figuring out, if the bottom and top number are both divisible by a number, that will save you some times. So knowing your divisibility rules can be helpful in that regard. Next, this can help you to identify multiples of a number. Okay. The last reason that I got down here kind of deals with this. In turn, you can also identify prime numbers, because if the number does not have, basically a prime number is a number that doesn't have any factors other than one in itself. And, by using divisibility rules, you can sort of weed it down to, if you check, okay, it's not an even number, it's not divisible by 2. It doesn't end with a 0 or 5, so it can't be divided by 5. It also, if I can't divide it by 5, because it doesn't, it's 0 or 5, let's say it doesn't end with a 0, that also means that you can't divide it by 10. Okay, then you start trying 3 and 9, and then eventually you'll start to figure out that a number can only be divided by 1 and itself, and you will recognize that it's a prime number. Okay, there are some other uses for it as well, but these are just some of the basics that you're going to encounter when you're, doing some basic math and working with numbers. Anyways, I hope that helps. Please give it a try. I hope it will help you in solving some problems. If you have any questions, please leave them in the comments. And yeah, if you like the video, please like and subscribe. Thanks, guys. See ya.